What is this time period? The time taken by the wave to complete one complete cycle can be termed as time period. It is maximum at the extreme positions, whereas at mean positions its angular displacement is said to be 0. Frequency is always equal to reciprocal, means it is inverse of the time period t. So this is the relation of frequency as well as time period. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to Chapter 14, Session 1, and chapter name is Oscillations. So this is a new chapter which you are going to see today, and oscillations means it is a kind of motion. So let us study first of all what is meant by a motion. So motion means it is the movement of objects. An object is said to have a motion, okay? So when a force is exerted on an object, it moves. How can you say that the object moves? Because of its displacement. So displacement tells us that the object is under motion and the object is moving. So here in this today's class, let us study regarding oscillations. So under oscillations, we have two types of motions, that is periodic motion as well as we have got as oscillatory motion. So what is meant by a periodic motion? So periodic motion means period. It means it's a time. So motion depends on the time. Motion with respect to time is said to be a periodic motion, that is one complete cycle. Okay, so the motion which repeats itself, it keeps repeating after certain interval of time. That is, after one complete cycle, again the movement of the particle at certain interval of time, and it completes that cycle. So repeated cycles of a wave or of a particle which represents a wave can be told as periodic motion. So that is all about your first one, that is periodic motion. Now let us go to what is meant by oscillatory motion. So here motion means movement of the object. So what is this oscillatory motion? This oscillatory motion can also be called as vibratory motion. We can call it as vibratory motion. So what is this oscillation or vibratory motion? That is back and forth movement. Back and forth movement which is repeated is said to be oscillation. Suppose you consider a pendulum clock, simple pendulum. You can see when the clock strikes at certain hours, what happens to the pendulum? It keeps on moving, correct? When a pendulum moves, you can see there is a movement. If this is the 0th position, that means it is a mean position, and you can see your pendulum moving from here. This is a mean position to this way and back to this way. So this is a body moves back and forth. So back and forth movement of a body is said to be oscillation or oscillatory motion. It is a to and fro movement of an object. So if this is a mean position and there is a suspension of any object in a vertical direction, when we just give a pull and just drop it, that is you're giving a force, what happens? It goes like to and fro movement. This to and fro movement about their mean position is said to be a oscillatory motion, or else it can also be called as vibratory motion. So that is all about the concept of motion under oscillation. That is just a general introductory part. We have got period and frequency. So when we consider a chapter waves, we had discussed about basic terms that we had to understand: amplitude, period, frequency, wavelength, wave velocity, etc. So here, let us study regarding period as well as frequency, because wave is always associated with this oscillations, okay? So here we have got period and frequency, what we are discussing about. So what is meant by a period? Period means it's a time which is taken for a one complete wave. To finish off one complete wave, the time is set up. So that time is said to be known as time period. So what is this time period? The time taken by the wave to complete one complete cycle can be termed as time period, which can be given as capital letter T. This is a symbolic representation of time period. So next we are coming to frequency. So what is meant by frequency? Frequency means at certain interval of time, how much of number of waves is present in that interval of time. So if suppose you're considering from here to here as certain interval of time which continues, how do you conclude this frequency? It is nothing but just giving a waveform. So how many number of waveforms are formed within this time period is said to be frequency. It depends like how many number of waves are formed in one complete set, that is per unit time interval, it can be called as frequency. So I hope you're clear with the period as well as frequency here. So how will you give this frequency? So frequency is given as it is equal to. So suppose you consider this nu as a symbol of frequency, then the frequency is equal to reciprocal of the period. So frequency is always equal to reciprocal, means it is inverse of the time period t. So this is the relation of frequency as well as time period. So I hope you're clear with the period as well as frequency for now. Now, let us go into displacement as a function of time. Suppose you consider a oscillations, that is a vertical oscillation of a loaded spring. You consider a spring which consists of a block which is having certain weight. Okay, it has got mass and it exhibits certain weight under what? Under gravitational force. If that is the case, what happens here? That is, if we are considering a vertical oscillations. So this is x-axis is said to be a horizontal one, y-axis is said to be a vertical one. Suppose if there is a spring and a block is placed below the spring and you just leave the block, what happens to the block? Since it has got certain mass and the weight due to acceleration due to gravity is acting on a block, it starts stretching. Suddenly you remove the block. What happens to the spring now? It oscillates to and fro. It comes up and down about its mean position. So this oscillations, that is the vertical oscillations what we are talking about. Okay, so here the load attached to the spring undergoes displacement along a vertical line. The distance from the mean position to any of its path is called as linear displacement, which changes with respect to time. That is what I was talking about. So suppose if you place a block below the spring, what happens to the spring? It stretches, and it stretches from its mean position. That is called as its displacement. You can call it as linear displacement, which changes with respect to time. This is all I wanted to discuss regarding the spring. Similar way, if we consider a suspension of any bob as shown in this diagram, so this point will be known as point of suspension. So it is suspended with the help of a string, and this is said to be a bob which is suspended with the help of a string. This is a metallic bob now. Okay, so here if we consider an oscillating simple pendulum, the angle made by the string of the simple pendulum at that instant of time is known as angular displacement. As we studied about the linear displacement, that is something with regard to the linear, only y-axis. Similarly, here there is a movement. Your spring moves up as well as down. Okay, so this movement is called as a linearly, it is getting displaced. Whereas when you consider a simple pendulum, that is a suspension of a bob, it is moving, it is taking the other direction, that is left as well as right, it keeps on moving. So that is known as to and fro movement of an object, which is known as oscillations, and this position can be told as, that is point B is the mean position. So there is a movement of this object, that is a bob, in to and fro motion. So about its mean position, then it undergoes oscillations by making certain displacement, and that displacement is nothing but angular displacement. Why angular displacement? Because it makes theta from this mean position. There is an angle theta when you calculate. That is, if you consider OAB, the angle between OAB is theta. Again, COB, the angle is theta. So it makes certain angle, and by that angle it is getting displaced at a certain distance. So that displacement can be called as angular displacement. So I hope you are clear with the linear displacement as well as angular displacement. After which we will be studying, that is, at extreme positions, the displacement is said to be maximum, and its mean or equilibrium position, the displacement is 0. Suppose if you consider a spring. So this is a block which is fixed there, and if suppose you consider this is the mean position MPL, right? So if that is the mean position, at this point its displacement is 0, whereas at this point it has got its maximum displacement, and after it pitches back it has got maximum displacement, but only here the displacement is said to be 0. Similar ways it goes with this bob also. So here the displacement is said to be 0, whereas here, that is at point C and point A, it is maximum. It is maximum at the extreme positions, whereas at mean positions, its angular displacement is said to be 0. So that is all about your linear displacements as well as angular displacement. So that's all about these two displacement, what you're talking regarding with respect to time. Now let us move to simple harmonic motion, that is SHM. How will you explain the simple harmonic motion? It is defined as oscillatory motion. So what is oscillatory motion? It is a to and fro movement. So simple harmonic motion is nothing but it is an oscillatory motion about a fixed point, that is a mean position. So suppose you consider a oscillatory motion. Generally we consider an object which is suspended, and here it undergoes oscillatory motion, that is to movement and fro movement, to and fro movement. This is the suspension from where it is suspended. So this will be your mean position. This is the extreme positions. Okay. So here we have got, it is an oscillatory motion about a fixed point, and that fixed point is the midline which is at the center. Oscillatory motion about a fixed point satisfies two conditions, which are those. The first point, the restoring force is always proportional to the displacement from that point. So the restoring force, what is this restoring force? The force which gets back again. It restores its point. So suppose you consider a spring. Once it is stretched, again it gets back to its mean position where it was coiled exactly, that is completely. It gets back to its original position. It moves front and gets back to its original position. That is, for example, you can consider an elastic material called as rubber band. Whenever you pull the rubber band, what happens? It stretches. Once you leave the rubber band at from any one of the side, what happens? It goes back. Okay. So people get hurt, correct? So it goes back and hits your finger because it's getting restored itself to its original position. The same thing, the restoring force is proportional to the displacement. How much ever your displacement you give, so much will be your restoring force in order to restore to its original form back. So restoring force is always proportional to the displacement from that point. So that is first point. What about the second point? So second condition, it is nothing but the restoring force is always directed to the point. Which point? It is the fixed point what you are talking about. Always, if you just pull, this is the motion, whereas this is the back to position will be the restoring force. That is what it is said here. It is directed towards this point. Again, you just pull your bob which is suspended and leave it. Again, it gets back, it restores back to the same fixed point or a mean position. So that is all about your simple harmonic oscillations, that is simple harmonic motion, SHM. So again I'll repeat this, that is an oscillatory motion about a fixed point in which the restoring force is always directly proportional to that of the displacement which is taking place, as well as the same restoring force is always directed towards the point. So that is all about your simple harmonic motion. Now let us move towards simple harmonic motion as well as uniform circular motion. So now we have got a simple harmonic motion as well as circular motion together we will have to consider. So now let us consider a circular motion of a particle. So simple harmonic motion is the projection of uniform circular motion. It is what? It is a projection of uniform circular motion on the diameter of the circle. So we will have to project uniform circular motion on the diameter of the circle, that is termed as simple harmonic motion. So in order to consider this, we will have to consider circle as well as its diameter. So suppose you consider a circle, it is having diameter which can be given as A, the points can be named as B, C and D, and the origin is named as O. Suppose you consider there is a particle which is following the circular path which is moving on the circumference. So consider particle P which starts from A. At that time what happens to the particle? It is the one which is moving on the circumference. So you can see there somewhere here at this point the particle P is present for at certain time interval T. Now you will have to project the SHM, that is simple harmonic motion, on the diameter of the circle. So which are the diameters here? CA, that is AC, as well as BD are the diameters which is present over here for this circle, and you have to project on this diameter. So let us consider the foot of the perpendicular. So when you just consider foot of the perpendicular, it will be the perpendicular drawn from point P, that is the particle P. This is the projection which is made on diameter BOD. Okay, so when you do this, just give a diagonal representation for it, that is from origin to particle. What is the representation? And you're drawing a perpendicular to your y-axis. So let me extend this, let it be y-axis. If I extend this, it will be x-axis. Okay, so here again draw a perpendicular to the x-axis. So you have got your two perpendiculars and you're considering this foot of the perpendiculars which is named as R and Q. So after P you have got Q and R. So this makes an angle theta from here and this makes an angle theta from here. So we have got two angles for this. So now what let us do? So now we have to, as a particle moves, it has got certain velocity. Having certain velocity, the particle is said to move. That means it has got certain displacement now. So how will you calculate? As we all know in general, velocity is equal to displacement by time taken. So we need to check the displacement. So displacement is equal to velocity into time taken. So what is the displacement which is undergoing? So you will have to check displacement is nothing but the angular displacement what it's taking. So that will be angular, means it is theta. So I'll give it as theta is equal to what is V? V is the velocity. That is the velocity. You can give it in terms of omega into T. In terms of circle, theta is the displacement, velocity is given by omega and it is T. So we have got theta is equal to omega into T, which is said to be equation 1. And you can see the particle is moving in a uniform speed, and there is a perpendicular which is projected on the foot of the perpendicular is considered to be certain diameter of this circle, and in this diameter, that is a foot of perpendicular, there exhibits a SHM. So your simple harmonic motion is considered to be in this diameter. So when you consider this, you will have to consider this diameter and you have to give the displacement which is given by O and R, that is said to be Y. So I'll consider the displacement of the particle is given by OR is equal to Y. So if this is the displacement which is given, then we will have to calculate for certain triangle which we are considering the displacement. That is, we are taking only this R and O region. This is the region what we are considering for our reference for now. So when we take that region, what are the conditions? It's like we have got OR is equal to Y, that is its displacement. And when we consider this triangle, what are the things we have got? This is opposite and this is hypotenuse, and this will be the base or else adjacent. So we have got opposite as well as hypotenuse but not adjacent, and something with the opposite and hypotenuse is said to be sine function. So when I'm talking about sine function, we have got sine theta is equal to opposite by hypotenuse, which can be given as, what is opposite over there? It is nothing but OR. OR divided by hypotenuse is OP. So OR is replaced by this Y and OP can be replaced as, because the circle is having certain diameter and it has got the radius which is given by A, whereas the radius of this circle is given as A. So OP makes the radius of the circle. When OP makes the radius of the circle, that is from the origin to some point in the circle, is said to be a radius. So it is represented by A. So I'll consider this OP as A, which is equal to sine theta. So I can rewrite the equation as Y is equal to sine theta and A comes together. So it becomes A sine theta. So theta value I already know because I have given the displacement, that is theta is nothing but the displacement. It is given as omega into T. So we have Y is equal to A sine omega T. So A sine omega T. So this is the equation for simple harmonic motion in terms of sine function. So this is in terms of sine function. Similarly, we can go with the cos function as well. In order to go with the cos function, we will have to check the other triangle which is mentioned over here. That is the particle, from the particle there is a perpendicular which is drawn to the x-axis. So we have to consider the foot of the perpendicular which represents its propagation of SHM. So SHM is exhibited here in this foot, that is foot of the perpendicular. So when we consider that, now you consider this, the other triangle which I have done in a spiral way. So let me consider that. So if it is that triangle what we are considering, then we have got here we have got OR is equal to Y. Similar way, here we are considering O and Q. So this point is said to be what? It is said to be X, since it lies in X-axis. So let OQ be X-axis, that is X. Okay. So what happens to the function now? It is that we have got OP. OP is nothing but A because it's the radius, and other value what we have got, it is the adjacent, that is X. But right angle, that is perpendicular, which is also called as opposite, that has not got any value. So we have hypotenuse and adjacent. So we have cos theta is equal to A divided by H, that is adjacent by hypotenuse. So we have cos theta is equal to adjacent by hypotenuse, which can be given as, what is this adjacent? It is termed as X, and hypotenuse, it is termed as A because it resembles the radius. So we have got X is equal to A cos theta because A goes with cos theta, so A cos theta. So what is this theta? It is nothing but omega t. Once again you substitute, X is equal to A cos omega t. So this is all about the other equation in terms of cos function. So we have equation in terms of sine function and equation in terms of cos function for what? For SHM, simple harmonic motion having a uniform circular motion. So these diameters are the one on which the simple harmonic motion is executed by the particles. So it can be given as a simple harmonic motion. It can be given in this representation, wherein this is the origin, and if you're considering this as Q, this is the diameter on which the particle exhibits a harmonic motion with certain frequency, amplitude and time period. So this is all about simple harmonic motion, and such kind of a wave is said to be a sinusoidal wave. So here we have got what are the displacement terms exhibited by simple harmonic motion in terms of sine as well as cosine function. So if you get to know these equations, these are the basic concepts in order to know the oscillations chapter. So in today's class, we have studied about the motion, that is the periodic motion and oscillatory motion, or else it is also called as vibratory motion, and after which we studied harmonic motion, then simple harmonic motion as well as the displacement as a function of time and the equations in order to represent the simple harmonic motion in terms of sine function as well as cosine function. So in today's class, these are the topics which we discussed. Let us all meet in the next class. We're having the further topics about the same chapter, that is oscillations, in our session 2. Until then, have a good day. Thank you.